All right, let's do a few examples here. So let's do the first example. Gives us this polynomial. So we've got a polynomial, right? It has real coefficients. Okay, so no complex coefficients here. And they did give us this complex number as a 0. Okay, so if it's a 0, then, well, the first thing they want us to do is let's find all the other zeros. Okay, so if we want the zeros, the other zeros, then we know that if this is a 0, by the conjugate zeros theorem, or by conjugate pairs, we know that 3 plus 4i is also a 0. Okay? And if it's a 0, then we know what the factors are, right? So let's use that information to help find the other zeros. Okay, so let's use the fact that if these are zeros, then we know that x minus, or plus, let's do plus, and I'll do brackets here so we can see it. So plus, or minus, I'm sorry, minus. X minus 3 minus 4i, right? And x plus, not plus, minus 3 plus 4i. Those are factors, right? They have to be. Okay? Now, if I multiply these together, what do I get? Well, I get let's see, how do I want to do this? Okay, so let's just do the factor there. So we do x times x, so that's going to give us x squared. Okay, then we're going to do x times this, so that's going to be what? Minus 3 plus 4ix, then minus 3 minus 4ix, and then these multiplied together, so these multiplied together are going to give us what? It's going to give us plus 9, and then when we multiply these two terms together, then we're going to do the FOIL method here, or we're going to use the distributive property when we multiply these, just like before. So this is going to give us 9, and since we have plus and minus here, the middle terms are going to cancel out, and we end up with minus 16i squared. Okay, so now what I'm going to do is simplify this. Okay, and so this is going to give me x squared minus 3 minus 3x minus 4ix minus 3x plus 4ix. Okay, and then what is that? What happens here? This is going to be plus 25. Okay, now notice how, like I said, the imaginary numbers are going to cancel out. And what do we end up with? We end up with this quadratic. X squared minus, not minus 3, minus 6x plus 25. Okay, now why did I go through that trouble to do that? Well, because now I can use my synthetic division and divide this out. Okay? Now I could have done the synthetic division up here with these numbers, but I was thinking, well, if I just multiply this out, I get something that is easier to compute, right? Not that you couldn't do it using the C values here, but I thought, well, if I just use this, then I factor out both of them at the same time in a manner of speaking, okay? And then, so let's do that. So now, I can't use synthetic division. I'm sorry, can't use synthetic division because this is not linear. So if I want to use synthetic division, I could use these, right? But let's just use long division and divide this out. So, and see what we get left over. So let me erase all this. Okay, so let's do the zeros here. So we've got 3 plus or minus, 4i. And so now I'm going to take x to the 4th minus 6x cubed plus 28x squared minus 18x plus 75. Okay, and I'm going to divide that by x squared minus 6x plus 25. Okay. Okay, so now I'm going to, what? This is going to be x squared. So x squared times x squared is x to the 4th, and then minus 6x times x squared is minus 6x to the 3rd, right? And then 25 times x squared is 25x squared here. All right, now I'm going to subtract. And so if I subtract, this is going to become negative. That's going to become a plus. This is going to become a minus, right? So then these cancel and these cancel. And then what do I get over here? I get 3x squared, right? And then I'm going to drop down the 18x. And I'm going to drop down the 75. Okay, so now I'm going to do it again. So I've got 3x. So what times x squared is going to give me 3x? I'm going to do what? 3. So it's going to be 3. So now x squared times 3 gives me 3x squared. And then minus 6x times 3 is going to give me minus 18x. Right? And then 25 times 3 is 75. All right, so look at that. Now, obviously, since we already knew that both of these were zeros, so we should get 0. So that this shouldn't be surprising that everything cancels out and we get 0. Because what was the purpose of this? Not necessarily to get 0. If we didn't get 0, then that would tell us we did something wrong along the way. But since we got 0, then what does this tell us? Well, our quotient is x squared plus 3. Okay? So, that's what we want. Now we know that what's left over after we factor out the zeros, these two factors, the linear factors, 3 plus 4i and x minus 3 plus 4i and x minus 3 minus 4i, then we have our quotient, our leftover quotient is going to be x squared plus 3. And now we can factor this easily into, because this is a sum of two squares, right? So this is going to give us x, oh, hold on a second. This is going to give us complex roots, right? And in this case here, oh, what can we do here? Well, we could use the quadratic theorem, or the quadratic formula. So x squared, or not x squared, x equals so that's going to be 0. So this is going to be plus, so if we set this equal to 0, this is going to give us equal to plus or minus the square root of negative, because b is 0 in this case. So negative, or minus 4 times 1 times 3 all over 2 times 1, right? So this is going to give us plus or minus the square root of negative 12 over 2, which then is going to give us what? This is going to be 4 times negative 3, right? So this is going to give us plus or minus the square root, because we could pull the 2 out, because the square root of 4 is 2. Cancel with the 2 down here. We end up with the square root of 3i. And so the zeros then are going to be what? It's going to be 3 plus or minus 4i, and then also plus or minus the square root of 3 times I. All right, so now that we have those, B says, okay, factor F into a product of linear factors. All right, so now that we have those, now we can factor out our polynomial. And so we can write f of x equal to x minus 3 plus 4i times x minus 3 minus 4i. And then we have x minus square root of 3i, and then times x plus square root of 3 times I. Okay, and notice that we've got 1, 2, 3, 4 factors, right? So we've got 4 complex roots. which matches the degree of the polynomial. All right, and then the next thing, it says, oh, solve for f of x equal to 0. Well, now that we got it factored, then we could use the zero product principle, right? And so that means that when we solve for this equal to 0, f of x equal to 0, well, we get the zeros, the roots, right? So we know that x will equal three plus 4i, 3 minus 4i, and plus or minus square root of 3i. All right. Now, the thing is this is, if you look in the textbook, this might not be the way the textbook solved this, okay? But again, because of all the things that we've been learning in this chapter so far, and before, we've got a lot of things in our toolbox that we can use to get to the correct answer, okay? So definitely look in the textbook, look at the different examples of how they may have solved this, okay? It might be the same way. This is just what the way it occurred to me as I was working on it.